I have to show that the sum of consecutive odd positive integers is divisible by 4. I have to use mathematical induction to do that. So first we check whether the first two positive odd consecutive integers, what is the sum of them, is it divisible by 4 or not. The first two are 1 and 3. So the sum is 1 plus 3 is 4, so this is divisible by 4. Then we assume any positive integer k and the consecutive positive odd integer k, and the consecutive odd one is k plus 2, has to be plus 2, it has to be. So we assume that these two sum is divisible by 4, sum of these two, and if it is divisible by 4 we have to write 4p. So this is 2k plus 2 is equal to 4p. Now once we have made this assumption, since we are using mathematical induction, in order to prove this we have to see what happens for the next set of consecutive odd integers. So the next sets will be k plus 2, for this one the next one will be k plus 2, and for this one will be uh, k plus 2 plus 2, so basically k plus 4. So these are the next sets of odd positive integers. So we will see what is the sum of them, is it divisible by 4. So k plus 2 plus k plus 2 plus 2, so that's 2k plus 6, or we can write 2k plus 2 plus 4. Now we made this assumption that this is divisible by 4, so this could be written as 4p, can be written as 4p. So we can write 4p here plus 4. So this one also gives this kind of expression in the end, and this is divisible by 4 because there's a 4 there. So we have shown that the sum of consecutive odd positive integers, that is divisible by 4 basically. Any two positive integers, consecutive positive odd integers, the sum that is divisible by 4.